Welcome to the ET335 how-to video for the Quartus Verilog and POS KMap lab. Here I'm showing an example, and we're going to convert this circuit to a Verilog equation and go ahead and go through the whole procedure. Here I am at our Quartus. Let's go ahead and build a Verilog for our decoder circuit. So let's go ahead and start a new one next, and we're going to call this one, we'll go ahead and add another file here which may not work on our VMware, but I'm going to keep it separated, otherwise some of the files will overwrite. And we're going to call this guy decoder V. And we're going to go next. Yes, I want to create it. Let's see if I could go out and find a Verilog file on my desktop. Don't know if this has been tampered with or not, but we'll fix it. And we're going to go Cyclone 2. 484, and again, I'm not sure if this is necessary. I think we could pretty much collect anything because we're going to do a simulation. Alright, so let's go to Files. Okay, I grabbed our OR gate V off my desktop, so let's go ahead and save it as our decoder V. And let's go to File, Save As, and we need to get back to our location of our Altera, Project 3, and actually I've already got a file, and we want to replace it. Yes, we're going to right click this, remove it from the file, and we need to put in all of our all of our inputs: B, C, D, E, F, G. Already have a comma, so let's go ahead and copy. And our input is going to be all those. That looks good. Assignment LED, that's fine. So let's write our formulas. Okay, so we're going to have parentheses, A and B, A and B, parentheses, and parentheses C and not D, parentheses, and parentheses E and F, and parentheses not G, and H. Okay, let's see, we have our inputs, we have our output, we have our assignment variables, we have what looks like my formula, which I double check: A, B, C and not D, E and F, not G and H. Looks good. So let's go ahead and let's go ahead and compile it. See what we get. Not successful. That's not good. So let's go ahead and figure out how to troubleshoot it. So I'm going to go to Messages. Object H is not declared. Well, that's not good. Oops. Oops. Very clear in our errors what I did. I forgot my H. Let's try again. Yep, seeing more green this time. Good. Okay, we successfully compiled it. Let's go ahead and do a waveform output here. We're going to do new, University Program VWF, and we're going to go edit, insert, node, node finder. I'm going to list it, make sure that we got the right file there, and we do. Whoops. We're going to list it, and that looks like the correct inputs. Double arrow. Okay. Okay. So we're going to do a clock input, and we're going to make this 5 because it's not going to be enough. We got too many inputs, and it's going to be too large because the maximum's 1,000. So we're going to keep going up. 20, double it. 40, 80, 160, 320, and the last one is 640, which is under our 1,000. Good. So let's go ahead simulation. We're gonna use our Cordis, and it is not that important, so we're going to use it. And we're going to do a simulation. And I see green. That's good. And I see that thing pop up. Good. And let's see. I see a 1 here, a blip, and it's a decoder, and that should be the one and only. So let me use my snipping tool. And good. And we'll come back to that. Okay, let's analyze our input and see if it's the same as it should be. So we're going to look down this point here. All right, so this is, we have 1 1, which is our A and B, which is correct, I think, and 1 0 is our next one, C and not D, and here we have a 1 1, which should have been E and F. And here we have 0 and it must be 0, hopefully. No, it's a 1. Because G and H, and G is low. And yep, D is low and G is low. That's perfect.